please unmute yourself, Salman. Yeah, thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, everyone. I feel honored to have the chance to speak on such a notable topic today. First, I would like to thank you, Mr. Arshad Ayub, the head of the PSM committee, for encouraging and inviting me for today's session. Let me also express gratitude to our President, Mr. Mazharuddin Sheikh, as well as our Vice President, Mr. Safdar Ali Khan, and our Secretary, Mr. Abdullah of our ASSP Kuwait chapter for leading and planning a wonderful session on process safety management. And also, I'm grateful for Mr. Ujjwal Ritwik and all of the PSM mentors for continually educate us the importance of a process safety management program. It's wonderful to see you everyone, and we appreciate your presence for today's session. So let me begin by just outline my own background. My name is Salman Burhanuddin, and currently I'm working in Kuwait Environmental Remediation Project at KOC, and I'm total having 9+ years of experience in implementing and managing health and safety in the field of oil and gas petrochemical industries. And today I'm here to talk to you about the release of hydrogen sulfide at Aghorn operating Waterflood station. So here you can see the incident location. It is operated by Aghorn Operating Incorporated. So on October 26, 2019, the Aghorn Operating Incorporated Waterflood station near Odessa, Texas, the one Aghorn employee, he actually succumbed to toxic hydrogen sulfide gas that had escaped through a damaged pump. So his wife also fatally injured by the hydrogen sulfide gas, and while searching for him at the facility after he didn't return to his home. So our review of this event is about the unfortunate loss of 2 lives, but the lessons from this incident affect the multitude of other oil and gas facilities throughout the country that handle this kind of toxic gases. This incident was both tragic and unnecessary, and we urge companies, those operating oil and gas facilities, to understand the findings from this investigation and implement appropriate safeguards and trainings. And we need to work together to ensure that our workers and community members return home safely each and every day. So before going to this incident summary, we will first understand the illustration of Aghorn water flooding process. So the Aghorn water flood station is used as a part of a process to extract oil from underground reservoirs in West Texas. So basically there are 2 methods for extracting the oil from the formation. First is natural pressure, the oil we are extracting from the formation. And second one, the secondary method is like this, means we are injecting the water by adjacent wells to that particular wells, and we are creating a artificial pressure inside the formation. So the oil extraction starts at an oil well where pump jacks, these are the artificial pumps we are using. So it is used to lift oil from the underground reservoirs. So the oil come out from the ground. It is having some water, whatever oil is coming from the formation. So this mixture of water and oil, we are actually sending to this tank batteries. And here the water separates from the oil. So this tank battery is a group of tanks that are connected to receive crude oil from the well. The oil is then transported for further processing, and the water is pumped through pipelines to the water flood station here, and it is now called produced water, and it can contain residual oil and other contaminants such as toxic hydrogen sulfide gas and other impurities. At the water flood station, the produced water flows into a large storage tanks called a suction tank. You can see here, and the water then enters a building called the pump house. Their pumps are used to pressurize the produced water and inject it back into the oil field through injection wells like this. The injected water increase the reservoir pressure and displaces the oil, allowing a larger quantity of oil to be extracted. And at the time of incident, there were two pumps in the pump house, pump number 1 and pump number 3. They removed the pump number 2 for maintenance. So the pump house also contains a control room from which employees run the station, and typically the station is not continuously occupied. Then the employee which is actually operating this pump house or this station, they are calling as a pumper. So his responsibility is like that he has to visit twice per day to record meter readings and inspect equipment. If there is an equipment problem, the pumper is not at the station, so the alarm system triggers an automated phone calls to the pumper from this control room, and it is then the pumper's responsibility to acknowledge the alarm and go to the station to determine what is causing it. The station was also equipped with a hydrogen sulfide detection system, and that would trigger a separate automated phone call to the pumper on duty if it detects dangerous levels of toxic gas. So the system would also illuminate a rotating beacon light on top of the pump house. We can see here. It is the beacon light. If they detect the hydrogen sulfide, it has to be rotate and show the illumination. So we will go here for description of incident. So on the evening of October 26, the water flood station control system activated an oil level alarm on a pump, and 5 minutes later the phone system called to that particular pumper, alerting him of a pump malfunctioning. So at 6:38 p.m. the pump house control board registered a high oil alarm level, and phone record shows that after 5 minutes later the alarm system triggered an automatic phone notification to that particular employee. After receiving this notification, the pumper come to that flood station. He parked his car near the water flood station, and leaving his personal H2S monitor in his car. Then the pumper went into the control room where the control system indicated the alarm was for pump number 1, which we saw earlier here. Then the pumper were prepared for work on pump number 1, and the pump which could automatically start when enough water was available to pump to the injection wells, and it was still connected to its power source. And same time, the pumper did not de-energize that pump number 1. He closed pump number 1 discharge valve only, and partially closed the pump's intake valve. While the pumper was near the pump, he was overcome because of the water is leaking from that plunger of that particular pump, and he overcome by this hydrogen sulfide, and he fatally injured by this toxic gas. After several hours, when he did not return back to his home, his spouse, his wife also drove the car with his 2 children to the station to check on him why he did not return like that. Then she entered the Waterflood station facility and searched for him. She found on the floor in the pump house. Then she also overcome, because she don't have this kind of personal monitor and detection system also. So she also overcome by hydrogen sulfide, and she also fatally injured by this hydrogen sulfide gas. A short time later, the emergency responders approached the pump house, and they detected a very strong smell of hydrogen sulfide. So this required them to set up the command post like self-contained breathing apparatus. They found that the pumper and his wife deceased inside the pump house, and water is continuously spilling from pump number 1. Then the responders rescued the 2 children, those who are actually inside his spouse cars. Then after that, the CSB, Chemical Hazard and Safety Investigation Board from USA, they analyze these 6 issues pertaining to this incident. The one of is that the pumper was not equipped with his company issued personal hydrogen sulfide detection device, HOS monitor, when he entered into the pump house. And on the night of the incident, he forget his personal HOS monitor in his car. The second issue they detected is that they don't have the written lockout and tagout procedures and policies, but they relied on the verbal procedures without formalized training on the night of the incident. And the pumper did not properly perform lockout tagout to de-energize the pump before performing work on it. So instead, he started to close the pump's valves while the pump was still configured to be automatically operated by the control system. And as a result, the control system automatically turned on, and the water is containing hydrogen sulfide is escaped from the that shattered plunger, and it was continuously spilled out from that plunger. The third issue they discovered is that the confinement of H2S inside this pump house, there was no proper ventilation, inadequate leading to fatal concentration of hydrogen sulfide gas within that building. So this is also the major issue. The fourth issue they discovered is that there are lack of safety management system. For example, there was no risk assessment, no training, and there was no hazard identification program. The fifth issue they discovered is that the non-functioning of hydrogen sulfide detection and alarm system at the some of the facility detectors, and it was set to a testing mode, and so it prevented them from sending an alarm signal, and other sensors that were correctly set up were unable to send a signal to the control room, and as a result, the pumper was not warned of the toxic hydrogen sulfide. Either through a telephone alert or by illumination of the red pump house, this flashing beacon. And finally, they discovered that there were deficient site security problem. There were informal policy when an Aghorn employee is working at a facility, the exit gates are normally left unlocked. And on the night of incident, this practice allowed the that pumper's spouse to drive directly to the Waterflood station and enter into the pump house, and where she also fatally injured. Then, following the recommendation which is received from the CSB, there are some key lessons we learned from this incident. The employers, the organization should take action to ensure workers always use the required safety equipment. They have to mandate the use of personal hydrogen sulfide detection whenever they are working the area which are prone to be hydrogen sulfide. Then they have to develop a site-specific formalized and comprehensive lockout and tagout procedures and policies. The third is that they have to commission an independent and comprehensive analysis of each facility to examine ventilation and mitigation. And fourth is that they have to develop and demonstrate the use of a safety management program that should have to focus on protecting workers and non-employees from hydrogen sulfide. Then at facilities that handle toxic gases, gas detection and alarm system must be adequately designed, maintained, and it has to be tested. Then the last is that industrial facilities should ensure effective site security system. It has to be in place to prevent non-employees entering into that particular facility. So these are the lessons learned we have to implement in our facility. Okay, thank you.
Systems and fire and safety engineering. Now he is going to present us on the pig launcher incident. Mr. Tarique, now it's your turn. Please go ahead. Thank you.
Assalamu alaikum warahmatullah. Please allow me to share the screen.
Ramanat?
Yeah, it's enabled, but here is in two devices. One is
I think Tarique, you have multiple nearby people sharing, login from the network. Kindly disable that so that you will not have the echo, I think. Yeah, go ahead. Thank you.
Can you see my screen, sir?
Yeah, it's okay. Perfect.
Assalamu alaikum warahmatullah. Good evening, everyone. I'm proud to have an opportunity to speak today at PSM session. Also, I am honored and humbled to be invited to speak today's session by Mr. Arshad Ayyub Sheikh, the head of the PSM committee. I would like to thank our president, Mr. Mazharuddin Sheikh, as well as our vice president, Mr. Sabdar Ali Khan, and our secretary, Mr. Abdullah Khan, for facilitating and organizing a fantastic session on process safety management. I would like to thank our mentor, Mr. Ujwal Ritvik, and all PSM mentors for providing consistently and teaching us that a process safety management program is critical for any business that has highly hazardous substances on site. Today, I'm going to present you a lesson learned related to a pig launcher incident that was happened somewhere in North America in the onshore facility. Before we move to the topic, I would like to highlight some rough image overview so you can understand the incident that I'm going to present. Because pipelines means we all are working in the oil and gas, and pipelines are a fundamental part of oil and gas industry. And it is a primary transportation method of, for crude oil and natural gases, and even the refined products like that. So basically, what is pigging? Pigging is the efficient and effective method to clean the pipeline. Building a pipeline network, on the other hand, is a major task. And most pipelines means pay for themselves, like with the product they transport, they are expensive investment. So this investment should be properly maintained and monitored. For that purpose, we are using pigging method. Some may have confused why we are calling it pigs like that. It's a very typical word, pigs. Pigs get their name from the squealing sounds when they are inserted inside and moving through the pipeline. So it sounds like a squeal. So how we are carrying pigging. First, it's an steady state, like some moving state. For example, any service flow, and over the time, some period of time, like a rust deposited inside the pipe and made salt scale, which causes resistance in the pipe fluid. On that time, we are carrying pigging. So over the time of pipeline, pigging method we are using to cleaning the network, and that network is very large, and number of sectional amount like 10 kilometers, 15 kilometers, and there is online tracker also. But in the second, when we discuss about in the respect of pre-commissioning, the line could be half kilometer of, or like 1 kilometer, like a 10-inch, 24-inch. So different types of pigs available to clean the pipeline. So basically, the method of pigging is safe. Anything inside the pipe, like remaining hydrotest water, loose material, anything like when we are grinding or building any material deposited inside. So that all types of cleaning use the pigging method. Here you can see some typical example of pig launcher and receiver. There is a launcher and launch barrel. We insert the pig from here. Then you can see the upside vent valve and the downside drain valve. Then you can also see the kicker line, the downside downstream isolation valve. And also means the kicker line that is used to pressurize the upstream side of pig so it can be launched. Also, means these are the typical example component of the pig launcher. Here's the launcher and the receivers. Further, we move forward towards today's lesson learned. On June 25, 2012, at a production facility somewhere in North America, one of the global leading companies hired a contractor that state the guaranteeing safe pigging operation. So during a preparation of pipeline inspection, by using a pigging operation, a temporary pig launcher that was attached to a pipeline was overpressurized and failed. This incident caused one fatality and the hospitalization of 2 individuals. See here. Instead, the trap valve between the pig launcher and the pipeline had mistakenly been left closed, and experienced inline inspection team assumed that the pipeline valves were the proper position and started purging the line with nitrogen from nitrogen truck. When the initial pressure was applied, this pressure gauge on the pig launcher was apparently reached 0. So it seems like the urging the team to apply more pressure on the pig. They feel that pressure wasn't applied and increased pressure. Means it was believed that the gauges overranged within second of starting pumping, and that when the gauge needle was pushed up against the 0 stop, it appeared to show means like a 0 pressure. Within minutes, the temporary pig launcher was pressured beyond its mechanical burst pressure. Because the temporary pig launcher had no pressure relief device, it was finally pressurized beyond its burst pressure, resulting in an explosion. So incident never asked to happen. They happen as a result of single mistakes, and we look at the process safety factor. They are disastrous. Many lives were lost due to some minor error and decisions. So what was the root cause actually? So let's move. If we can't use the proper equipment at the proper place, it could be disaster. We shall have to make sure before doing any test on pipe. The first, that pumping equipment was capable of delivering pressure far in excess than the design pressure of the launcher. So, and the second, the risk associated with the high pressure to low pressure had not been fully recognized by the team. Eventually, there was no pressure relief valve on the temporary pig launcher. And it was also observed during the design stage, they did not consider the temporary pigging operation. We all know the importance of HAZOP. They did not specify the HAZOP. They did not specify the temporary pig launcher during the HAZOP. And the technique involving mitigation the hazards and implemented the precaution by a knowledge and professional team. So the operator increased the pressure, and then when the pressure gauge not deflected, means here competency of the working crew was not verified and assessed. Means they increased the pressure and did not observe and inform to the work crew why the pressure gauge is not working. Like it's look like and also the procedure did not specify the need of pressure relief device. Means it's look like a man planning to cook some sweets food, but don't have the sufficient recipe. It would become something different. Like there is also a thorough risk assessment not available and clear risk control not defined. Also, like equipment like PSD pressure safety device not calibrated and maintained, and inadequate training to the working crews is also not proper. Improper method of statement present at the work site. So what was the lesson learned? The design of temporary pig launcher and the PSD shall be verified by engineer team and approved by third-party inspection company. It's like a safety valve, relief valve, safety, and temperature and pressure, everything. They should have to first inspected by the approved company and calibrated. A pressure safety device must be calibrated on a regular basis. Next, a thorough risk assessment must be carried out and clear risk control must be identified. Means risk assessment are very important as they form an integral part during the process operation. Individual worker behavior is critical to, and also during the design phase, all activities must be clearly defined and stated in the HAZOP. And only competent workers shall be assigned to carry out the task. That means the individual worker behavior is critical for any organization, health and safety management system, and in any organization like that. If one worker behaves in an ideal safe manner, for example, but the other worker does not, so it means the other worker is endangered to others, like one safe persons. And the competency of contractor and its personnel should be verified prior to start of work. Procedure always need to be reviewed and updated accordingly by the safety experts. And we move forward. So the procedure always need to review and updated accordingly by the safety experts. Let's see the factor of process safety. We all know that difference between process safety and personal safety. That the accidents involving personal safety tend to occur very frequently, but often have little consequences. Conversely, process safety incidents tend to have infrequently, but can often have atmospheric result, like a catastrophic results when things go wrong. We are taking all the precautionary measures and strict guidelines, but again mistakes happen in the process, like a rapid overpressure, event gas leak, explosion, release of highly toxic or energetic material like that. So the first factor was the contractor management. We should always have to consider the contractor before we selecting any contractor. We should have to check and review the risk assessment and all the items like accident and incident history, policy, and everything. So in this incident, they didn't assess the contractor before hiring to start the pigging operation. Also, we have to check the mechanical integrity. Mechanical integrity is also a part of one of the 14 element part of the OSHAs, and it's very crucial. They did not assess the equipment, they did not calibrate any equipment, and they are just ignored during the pigging operations. They did not follow the procedure. So the mechanical integrity should be proper. And the third is the human error. We should now recent days, it shows that in the process safety, human error is a very catastrophic. And we are seeing multiple events. Like, for example, I'm going to share you a word like work monotony. It means the people are overcome by going to the work by day. So they are not having proper. They feel like a boring. If they are once they are going to the work site and they are doing the same work day by day, they feel like bored. So these types of human error shall be considered during the process safety operations. I would like to conclude this. Thank you.